Welcome. We're going to go over the first of 3 free response practice questions here as we prepare for the end of our forces chapters of AB Physics C Mechanics. Before I begin, just a reminder that you should have set a timer of 45 minutes for the 3 questions I gave you and attempted all 3 problems. If you have not attempted any problems, do not watch this video yet. It is far better for you to try and then identify what your mistakes were and practice those, than it is to simply watch this video and see the answers. So please trust me on that. Spend 40 minutes to really try, and then watch these videos. Alrighty, let's go ahead and go over this then. So we're told that we have this block of mass M, and one of the things that I really want to emphasize that's really important is to highlight information that you are given. So we're told we have a block of mass M that is pulled along a rough horizontal surface. So yes, there's friction, and it's going to be FFK because it's sliding. We're told that it's pulled with a constant applied force that is at an angle, so that's really important. And the acceleration of the block is A1. So as far as we know, A does not equal 0. Remember, that's important because that means that the net force does not equal 0. On the figure below, we are asked to draw and label the free body diagram showing all forces on the block. Now, in class, we practice drawing a free body diagram that shows where net force exists, if it does. Generally, if they want to see that, they will give you a scale, so that way you really can be clear about things being different. So the first thing that I, as a test taker, am noticing is the fact they didn't give me a scale probably means that they aren't looking for that obvious difference in the magnitude of forces that would produce a non-zero net force, but we'll do that just to be safe. All right, so first, gravitational force acts down, no different than usual. And then that must be balanced by normal force. And normally we would draw the normal force to be the same length. Now, one thing I'm going to do here is just erase this. They don't give us much space. I don't know why. I guess because you could do this all in a blue book with more space. But I'm going to make MG a little bit longer to help me with the drawing. Remember to always label. It says draw and label. You must label your forces to get full credit. We have F1 here. And the big thing is that F1 is at an angle relative to the horizontal. What that means is F1 contributes a little bit of upwards force. So my normal force cannot be as long as mg to make the vertical components balance. The normal force must be less than mg. So again, they didn't give me a grid, which tells me they're probably not looking for it, but we're going to do it just to be safe. In order to have acceleration to the right, I must have a greater force to the right than my friction to the left. So I'll draw friction to the left and call it mu k Fn, or you could write it as FFK. And I want it to seem to be lesser than the horizontal component of F1 to the right. All right, let's go ahead now and take a look at the scoring for that. And I think you'll find that you really can get a lot of points for doing these free body diagrams if you know them well. So 4 points for each of the forces shown above with the arrow correctly drawn and labeled. 1 point was awarded. So notice how 4 points out of 15 is pretty significant for doing something that really probably doesn't take more than a minute or two. And so anytime you see a free body diagram, I would always suggest that that be the first thing you do. Grab those points. And then for the next section, it really shouldn't take too much more work to then write your Newton's second law equations, right? Derive an expression for the normal force, derive an expression for the coefficient. They don't want you to simply write the answer. Okay, when they say the word derive, it is a very important word. It is saying show all of your steps. It is saying pretend you are the teacher teaching this to a class. Show all of the steps you would need to get there. So writing that the sum of the forces in the X is equal to F1 cosine theta minus mu kFn equals max. And saying that the sum of the forces in the y equals Fn plus F1 sine theta minus mg equals 0, because ay equals 0, is really important. Writing these two things is really important. Let's take a look at y. So if we take a look here at the scoring rubric, the two derivations in total are 5 points. So if you can write the diagram and write the equations, that's 9 out of 15. That's a significant number of points. That really gets you close to where you want to be for a 4 or 5, right? So the first thing they want you to indicate is that the sum of the forces equals 0, and as a result, the correct y component of F1. So they want you to write that the normal force plus F1 sine theta minus mg equals 0. So that's what we just wrote, right? So that earns you a point. And notice below, for writing F1 cosine theta minus mu k Fn equals m1a is the second point. So we're now, if you can do the diagram and do the chart as we've practiced, you're at 6 points. And then the rest of it sort of flows from there, right? You should be able to get the 7th point by just solving this equation for n. N equals mg minus F1 sine theta. That should be good. So now you are at 7 points. The next one is for substituting the expression for n. So substituting what you get into B into C earns you a point. And this is a helpful time to talk about follow-through credit. When they ask you for n, whatever you write that n equals, be consistent. All right, let's say that you accidentally wrote n equals mg and you didn't think fully through the problem. If you substitute n equals mg, notice how it says for substituting the expression for n from part B earns you a point. So it doesn't matter if B is right, you still get credit for knowing to substitute in that Fn value. All right, and then for the correct answer. So generally, again, if you messed up B but you are consistent, you would get the point because it's correct given your previous mistake. But otherwise, it would be F1 cosine theta minus mu. Notice how the mu here is the thing we want, so you need to move the F1 cosine theta over, but it's a negative mu, so we need to multiply by a negative 1 on both sides. So even though I would have ma minus F1 cosine theta, when I multiply by negative 1 on both sides, it's going to flip from ma minus F1 cosine theta to F1 cosine theta minus ma, and then we divide by this piece here to get our final answer. All right, and so that then makes our 9th point. After that, we are asked here to sketch graphs of the speed v and displacement x of the blocks as a function of time if the block started at a position of 0 at time t0. Right, so we are told that the force does not change, so that means that the net force is constant, right? And if the net force is constant, then the acceleration is constant. So given the fact that when acceleration is constant, a equals some constant, then velocity would equal that constant times t to the first power. V must be linear, as best I can with a touchscreen. And then the position is the second integral of acceleration, right? So the position then would need to be c times t to the second power. So position would need to be quadratic. All right, let's look to see what they want here. Okay, for the scoring, 3 points. For a linear relationship on the v versus t graph with v equals 0 at t equals 0. For a parabolic relationship with x equals 0 at t equals 0. And then the final point for the graphs being consistent. So let's say that you goofed up v. Maybe you made it slowing down. If the position versus time graph showed the same thing, you would still get a point. So you would still get a point out of those three. But otherwise, notice these are all things that you guys are definitely capable of doing. That's 12 out of 15. I don't think it takes that long. 12 out of 15 is fantastic. So even if you get to the last one and you're uncertain what to do with the last one, well, you've certainly gotten more points than you really need for this problem, and you could move on and come back to E if you have enough time. All right, otherwise, let's take a look. If the applied force is large enough that the block will lose contact. So that's the thing that we really want to highlight here, this statement of losing contact. And you want to think about when we lose contact, what force is that relating to, right? The contact force is the normal force. If we lose contact, then we're saying that normal force is going to 0. This is right at the moment where we're about to lift off of the ground. Derive an expression for the magnitude of the greatest acceleration, A max, that the block can have and still maintain contact with the ground. So what that is saying here is that in this equation, F1 cosine theta minus mu kFn equals max that we derived up here. This Fn is going to 0. So what would that Amax be? So if Fn goes to 0, then essentially we have no friction. And if we have no friction, then the first part that we would write here for that equation is that F1 cosine theta equals m1ax. So now things are frictionless. It also affects what's going on up here, right? And we're going to develop a system of equations. Normal force here is going to 0. So now F1 sine theta is going to equal mg. That's helpful because I can solve for F1. Notice that it says at the very beginning, express all algebraic answers in terms of m, F1, theta, and A1. So this is one case where I could actually leave things as F1. Sometimes they'll say not to, though. So let's say that were the case. Just to talk about that, I could solve for mg divided by sine theta as F1 and substitute. And so then I could find, okay, max would equal mg times cosine theta over sine theta. Notice that the m's go away. And this A max would be at g cotangent of theta. Let's take a look at what they're looking for. So the first point, for indicating that the normal force is 0, is the condition for maximum acceleration when it loses contact. 1 point. So we did that. For indicating that the friction force would be 0, another point. So notice here that you could get 2 out of 3 in very quick time by saying normal force must be 0 and the friction force will be 0. You could skip the derivation for that last point, and if you are getting 14 out of 15, boy howdy are we happy, and life is good, and you move on and keep snagging some other points. Right? But since we're practicing, it's good to understand. Notice their note. Since F1 is a variable quantity in this problem, and since the initial directions included F1 as a quantity that could be used in the expression for the answers, the expression A max equals F1 cosine theta over m was also acceptable. What this note means is that they probably did not intend for that to happen. They probably intended for this to happen, A max equals g cotangent. They made a mistake in the instructions. And because they made a mistake, tons of students wrote this, and they had to modify their rubric to allow that. So the thing they wanted is what we did, which is to get rid of the F1 and to instead derive this just in terms of g and trig functions, g cotangent theta. But if you did it the other way, you earn the point. So hopefully you guys are anywhere between 9 and 15 points right now. Remember, it's just November, right? We have December, January, February, March, April, May, a little bit of May, to prep. So it's okay if you still have room to grow. All right, so thank you for watching. Don't forget to complete the reflection so that way you get your completion quiz grade credit, and have a great rest of your day.